All right, hello everybody. Unit 9 tests are graded. You should have gotten those feedback Google Forms back from me yesterday. Please email me if you have any questions. We are going to actually jump back into our trig unit today. So I thought we'd just start with a quick review of what we did prior to our release into e-learning world. So we're going to start with the basics again. We're going to start with right triangle trig, sine, cosine, tangents. I filled in a little bit of this for you already, so you guys can skip through if you know this, but take the time to watch it. Make sure it's fresh in your memory if you're not quite remembering everything. So remember, when we label the right triangle and we use trig functions, we're always relating angles and sides. All right, so you see that in the first part. As we look at this right triangle here, we use this Greek letter theta to denote our missing angle. Now, when we label the sides are always relative to theta. So I put that here, sides always relative to theta right down here. So when we want that angle, whatever this missing angle is, or we're talking about this angle, our opposite side is here. That means our adjacent side is here. Our hypotenuse is always across from the right angle. Okay, so don't be afraid to label those as you guys are working with these. All right. So as we talk about theta, again, remember it's a Greek letter. Think of it's a variable. Think of it as the missing angle or the angle that we want to know or want to use, okay? So here's our 6 trig functions now. I'm going to just kind of chat a little bit about these, and you guys can write them down in your notes if you have them. Otherwise, just kind of listen, make sure you're good. All right, so remember, as we write our equations for our trig functions, we're always relating one angle and 2 sides, okay? We use this acronym SOHCAHTOA right here to help us remember these. Okay, don't be afraid again. Write that down. Say it. Think about it. Write it down. SOHCAHTOA gives us these formulas right here. Okay, sine opposite over hypotenuse, and remember that is the side opposite whatever this angle is here. Okay, cosine adjacent over hypotenuse, tangent opposite over adjacent. Now we also introduced the reciprocal functions, and these simply are the reciprocals of sine, cosine, tangent. So the reciprocal of sine is called cosecant. Okay, remember, each of these reciprocal pairs have one with a co in it. Sine, cosecant. Cosine, secant. There's our co. Tangent, cotangent. So if you forget which ones of these match up your cotangent with tangent first, and then cosecant goes with sine. Cosine already has the co, so it goes with secant. All right, and we can see that these are just reciprocals. So if I'm asked to find all 6 of these, I always start with these 3 that I'm comfortable with, and then I flip to the reciprocal, flip to the reciprocal, and flip to the reciprocal. Okay? So there's a quick recap. Let's do a little bit of solving and see what you guys remember. All right? I'm just going to start here with number 1. Now, if I want to find 6 trig functions, I need to find all the sides. So the first thing we're going to do is we need to find this missing side. Let's call it B. Some of you guys might remember seeing this before and not finding that missing side. So to find the missing side, we simply use our Pythagorean theorem. A squared plus B squared equals C squared. Okay, so our legs are 15 and our missing leg. Make sure we plug these in the right place. And our hypotenuse is 17. So make sure we're setting it up like that, and then we can go ahead and solve. And on my calculator in this step, I just do 17 squared minus 15 squared on my calculator, and I get 64. So when I do that, kind of saves me a step of work. Square roots. Now I don't need to worry about a negative here because in geometry we're working with positive sides. So there's my side. My missing side is 8. So I'm just going to erase that B just so it's not confusing anybody, and make sure we know that we're using the side 8 here when we do our 6 trig functions, okay? Now that we have all 3 missing sides, you're really just testing yourselves to see if you remember these formulas. So notice where theta is. Opposite side is 8. So sine theta equals 8 over hypotenuse. Okay, and if it helps, why not label these too? So according to where my angle is, that's opposite, that's adjacent, and that's hypotenuse. All right. The more you write down, the more you label, the better you guys will do and not mix things up. Next one, cosine theta is adjacent over hypotenuse, so that's 15 over 17. And tangent theta equals opposite over adjacent, which is 8 over 15. So now, really, the reciprocal function is easy. You just got to remember to match which ones match. So remember that each pair has a co. So sine goes with cosecant, and we just flipped the reciprocal. Cosine goes with secant. Those are reciprocals. We flip it over. And tangent goes with cotangent. All right, number 2, exactly the same. Find that missing side. Write your 6 trig functions. Not a big deal there. But again, a necessary review for a lot of you guys, okay? All right, check these out. Now we have some missing pieces. We can use trig functions to find either missing sides or missing angles, all right? We're going to start here by finding missing sides. So notice, those of you guys that like steps, here's some steps for you, all right? So remember we talked about why we put circle to angle, and remember that's just there to make sure we're considering where that angle is, so we think about which sides are which. So that's the opposite side. That means x is the adjacent side, and that means 8 is my hypotenuse. So as we look at this, we can say, I want x. I don't really care about the opposite side right now, do I? I care about the adjacent side is what I want. I know the hypotenuse, and that means I need the adjacent over hypotenuse, which is cosine. So when you guys set up our equation now, we're going to use the cosine function, and we just simply write cosine 30 equals, now adjacent is x over hypotenuse is 8. And that's our equation. So we're using that trig function to set up an equation. So now we're just going to solve for x. Okay, don't psych yourselves out because this is the easy part. 8's on the bottom, multiplied by 8. Multiplied by 8. Now in my calculator, I'm simply going to put 8 times cosine 30. Make sure we are in degree mode. You haven't touched these calculators for a while, so go to math. Go to mode. If you're in math, hit second quit. Go to mode right up there on the top. Make sure when you arrow down that you see the degree is highlighted and not radian, because I'm going to put in 30 degrees. So I'm just putting 8 times cosine 30. And we get x equals, this is where we'll round to the 100th, 6.93. There's our solution. All right. Notice 6, we have an angle, we have 2 sides. One missing, one we know. Look, all these are the same. All have one angle and 2 sides. One missing and one we know. So let's go ahead and do one more. All these are pretty similar. There's not big differences between any of them. Let's go ahead and do number 8. So here's our angle. Side we know is opposite. Side we want is hypotenuse. Which trig function compares the opposite and the hypotenuse? And hopefully you're saying that is sine, Mr. Chalmecki. So we set up our equation as sine of 24 degrees equals 11 over x. All right, now x is in the bottom here, and this is what threw you guys off a little bit sometimes. But you remember, it's the same thing like when we did up here. Whatever's in the bottom of that fraction, we just multiply both sides by it. All right, so whatever's in the bottom of the fraction, we multiply both sides by that. Okay, since it's the x's cancel here, and now we get x times sine 24 equals 11. So rewrite that equation and make sure you're putting things in the right places, because now to solve for x, I just have to divide both of these sides by the sine of 24. And notice, I'm not putting this in my calculator till the very end because I don't want a rounding error. So now this is what goes in my calculator. 11 divided by sine of 24, close the parentheses, hit enter, and we get x equals 27.04 when I round it. Okay. So that's it. Try these ones out. These are good practice for you guys. I'll put the full solutions to these notes on the drive for you guys. But I don't think you need more than that from me. I think you just need to practice these if you forgot how to do them. All right. So here we got a little box. When we're looking for angle measures, we use, so now here's the next part. When we're looking for the sides, we use the regular trig functions. When we're looking for angle measures, we use inverse trig functions. And hopefully that's ringing a bell. If it doesn't, that's why we're reviewing today. So don't worry about it. It'll come back. All right. So here we go. Find angle N. Angle N is right here, guys. So look at which sides we know. We know the opposite side, and we know the hypotenuse. So just like we did before, exactly the same. We start the equation the same way. The difference is when we set it up, we're not going to know the angle. So first we say, I know opposite, I know hypotenuse. Which trig function relates opposite and hypotenuse? And hopefully you guys are saying, oh, that's sine. We just did that one. And when I set up my equation, that means I get the sine of angle N equals the opposite is 6 over that hypotenuse is 10. All right. So now you might be thinking, how do we solve this? This is when we use an inverse trig function. So algebraically, what we're doing is we're taking the inverse sine of each side. And the reason we're doing this is because we need to cancel this out. So when we take the inverse function of any function, we get back whatever it started with, which in this case is angle N. And over here, this is where we're going to put in our calculator inverse sine of 6 over 10. Now again, we want degrees back. We're in degree mode already. If you didn't check that yet, you better check. Always check when we start. So we're going to hit second sine. So we hit see that sine to the -1 power. That tells us we're doing inverse sine, which again means we're going to get back an angle this time. So angle N equals 36.87, and please label those degrees. Remember that we are in degree mode talking about degrees. Okay. All right. 12 is just the same thing. All you're doing is taking inverse cosine, inverse cosine. So the equation's already set up for you guys. This is all you have to do if you see something like that. Inverse cosine of 5 over 7. There's no setup or anything you have to do. All right. So inverse cosine of 5 over 7. We get theta equals 44.42 degrees. No big deal. Go ahead and try out number 11 on your own as well, guys. All right. Let's keep cruising. Hopefully you guys are doing okay with this review. Remember, at any point, if something's not making sense, please just pause and send me an email. All right. I know a lot of you guys are using things like Khan Academy and YouTube videos. Please continue doing that. Whatever works for you, do that, okay? All right. So let's look at the next one. So I don't see any variables in here. So you guys might be wondering, what do I need to solve for? All right, when you see these directions, solve the triangle, it means find all missing sides and angles. Okay, that's what solve the triangle means. So notice we already have two sides. We can find the third side pretty quickly using Pythagorean theorem. So 8 squared plus 15 squared equals our hypotenuse squared. I'll just put that in my calculator. 8 squared plus 15 squared equals 289. So c squared equals 289. Sorry, my screen's bouncing around a little bit as I write. And square root of that's 289 gives us 7. So there's our hypotenuse. So if it helps you to do that one first. All right. I also like to do this as I'm labeling everything and thinking about what I need. I'll write all the sides over here. So start with what we know, yz equals 15, zx equals 8, and then we got yx equals 17. All right, now when we do our angles, we're just going to name our angles with the vertices. So we got angle y equals, we don't know that one, angle x equals, and angle z we know is 90 degrees. So even though with solving the triangle it seems like it's a lot to figure out, it's not that much, okay? Because all we have to do now is one trig function, and you guys can pick whatever you want. So let's say we want to find angle x, okay? Use your favorite trig function because we got all the sides, we can use whatever we want. We like sine, the opposite is 15, so we're just going to set up sine of x equals the opposite over the hypotenuse. And all we have to do then is inverse sine of both sides. And we're going to take inverse sine of 15 over 17. And that's going to get us back our angle x. So in our calculators, second sine, 15 divided by 17, and then we get angle X equals 61.93 degrees. 61.93 degrees. Now we could do another trig function to find y, or we can simply say we know the angles in a triangle add up to 180, so 180 minus 90 minus 61.93 gives us 28.7, sorry, 0.07. I guess something didn't make sense there. 0.07. And there we go. We solved the triangle. So remember, that's all that means. And again, you can choose any trig function you want because we know all the sides. If you're limited on sides, then that's going to limit what trig function you can use. All right. But similarly here, we can start by finding that missing angle. So we know all the angles add up to 180. Subtract 180 minus 90 minus 41.4, and we can get this angle right here. And I'm not going to finish this one completely for you, but again, you can use either angle, you can use either side, whatever you want, okay, to set up your equation. So let's start with the first one. Let's say sine of 41.4 equals, I'm going to use the opposite side, which is zx, over the hypotenuse, which is 16. And then you can go ahead and solve that. Okay. Once you get that, you can use Pythagorean theorem, or you can do another trig function. All right, pause, finish that one up, check it out. Let me know if you have questions. All right, I think that's it for today. Is that all I got for you guys? That's it. That's our trig review. All right, I'm going to post homework so you guys can start working on that, but hopefully this will come back to you pretty quickly. If you didn't look at the assignment sheet, I posted that assignment sheet on Monday. Take a look at that on Monday so you kind of see where everything is due and where everything's happening. You guys can submit homework at the end of the week. You can submit homework at the end of the unit. The grade for homework is optional, but again, I do recommend that you guys practice. These skills are really important for you next year. So if you're not practicing, it's really just going to be on you, and you're going to be struggling next year. There's no other way to put it. All right. I will do everything I can to help you guys out, so please keep emailing me. Let me know what questions you have. All right. Talk to you later. Hopefully see you at Google Meet sometime soon.